Hi, okay, how you doing? Thanks for tuning in. Right, in this video we're going to do interpolation. That's not one that gets the juices flowing really, is it, in terms of, yeah, exciting, let's do this, you know. I really want to do some interpolation today. Yeah. But, you know, it's something that's got to be done, right? The way I look at it is it involves some precision in mathematics to actually get to the result you want, and it's the precision thing that I'm really fascinated about. Okay, so no, it's not calculus, no, it's not trigonometry, no, it's not graph sketches, not even algebra. It's just a statistical concept. Okay, it needs to be done. Okay, but we're gonna do it. Okay, and hopefully you'll see why this actually can be quite enjoyable. Okay, remember, it's the precision that matters. So what is it about? What is interpolation about? Okay, well, it's about group data. So here we've got some figures, height in centimetres and frequency. Okay, it's about trying to find an estimate of the median and the quartiles and percentiles if you so choose. Okay, and finding averages like median and finding quartile range, measure spread is quite useful, isn't it? Okay. In the real world, of course, when you're dealing with maybe thousands, tens of thousands, hundreds of thousands data items, we don't list them all, do we? We put them into a table like this, a grouped frequency table it's called, okay? And sometimes we're interested in finding percentiles or quartiles or the median, okay? So I'm going to show you how we use interpolation to do it. First of all, this is an estimate, okay? It's not an exact value, okay? This is an estimate, but the mathematics we use to get our estimate is actually a precise method. I'm hoping that makes sense. We'll use a precise method to get an estimation. Okay. The reason that works is because it gets us the best possible estimate. Okay. One assumption we're making is that the classes are what's the word I want to use? Okay. Evenly distributed. Thank you. The classes are evenly distributed. Okay. That's one of the assumptions that we're going to make. Okay. So assume that with this frequency of 8, there are 8 values evenly distributed. Okay, that's just one assumption we need to make. Okay, but bear in mind, that's not always going to happen. That's why it's called an estimate. Okay, so we're going to look at trying to find the median. Okay, well, Q2 is what we often use to abbreviate median. Q1 lower quartile, Q2 median, Q3 upper quartile. Okay, and the technique is we of course work out how many data values there are altogether. So what's this? 30, 65, 80. Okay. So the median is going to be halfway through it. Now with continuous data, which we're dealing with here, with continuous data, we do half of the number of data items. Okay, so half of 80. So we're looking for the 40th value basically. Okay, we're looking for the 40th value. Now at the moment, even if you've not even heard of interpolation, okay, you can determine which class interval it lies in. You just want to have a think about that for a moment? Did you pause the video? That's the whole idea about these things. When I say do you want to think about it, just give the video a pause and think about it and then play it again. Otherwise I'm going to blurt out the answer, aren't I? Okay. Well, what you might do to help you is add on a cumulative frequency column. Okay, like you did in the good old GCSE days. They seem a long way away now, don't they? The GCSE days. Okay. So we've got 8, we've got 30, we've got 65, we've got 80, of course. You can see the 40th value must lie in this class, mustn't it? Okay, let's just put a little star there. Okay, it must lie in that class because the first 8 values are there, first 30 values are there, and then the 40th value is somewhere in there. So that is going to be in this interval, isn't it? So I'm going to put there just lies in the, and then we call it that class, 160. Less into H, less than 170 interval. I'll put class because it's shorter to write than interval. Okay. So we know our answer's got to be somewhere between 160 and 170. This is where the interpolating bit comes in. Okay. Well, how far into that class does it lie? Okay. Well, the first 30 values are down there. So we're looking at the next 10 values, aren't we? So it must lie 10 units, if you want, 10 values into this class interval. Okay. How many data items are in this class interval? There's 35. Okay. So as a fraction, it must be 10 35ths into that class interval. I'm hoping that makes sense. Okay, so I'll say it one more time, okay? We know that the first 30 are in these two classes, which I'm kind of put my arm there to indicate we're there now, okay? And then an extra 10 to make 40, 10 units into this class here, out of a possible 35. There are 35 units in this class interval. So 10 out of 35, 10 35ths. 10 35ths into this class interval. Okay, that's a very important fraction. Okay, you'll need that in your calculation. Okay, 10 35ths into this class interval. Okay. How wide is this class interval? Okay, 10. Okay, the class width is 10. Okay, so effectively find 10 35ths of 10. So 10 35ths multiplied by 10. Okay, and that gives you a number. Okay, should we work that out? Yes, let's work that out. I came here with a calculator. Okay, this is one of the reasons why I find statistics less interesting, because every time you want to do something, you've got to pick up one of these. It takes the fun out of doing stuff, really. Okay, I know this is one we could possibly do in our heads, okay, but just bear in mind I've given you a simple example there, okay. Most of the time these turn out to be horrible numbers that you'll use a calculator for, okay. So that's 2 point, I'll write it down again, 2.8, I don't want to round that to 2 decimal places, if you don't mind, okay, 2.86 to 2 decimal places, okay, but just in case you want, there you go, 2.85, because I'm going to use it again in a minute, okay, 2.85714, okay. So what does that mean, okay, so that means within this data value we've got in centimetres, the 40th value must be 2.8 something centimetres into that class interval. So what's the overall height we need? Well, it's got to be 160, add on to that, isn't it? Okay, because if it's 2.85 something centimetres into that class interval, it starts at 160. Okay, so just add on 160 to that. Okay, so to make my calculation correct, I'm just going to include the add on 160 there, and then work out what that is. Do you need a calculator to do that bit? No. If you do, why on earth are you doing A-level maths? Okay, come on, sort yourself out. 162 point, just check around that correctly, 9. Okay, centimetres, and I'm going to put in there 1 decimal place. Okay, and that is it. Okay. Notice that's an estimate though, so our estimate for the median is 162.9, 163 if you add it up to one nearest whole number. Okay, I'm hoping that made sense to you. Okay. I want to talk you through how to do the quartiles next. Okay, the lower quartile and the upper quartile. I'm going to leave my calculator just there. And the disadvantage, of course, of having a small board in my garage is I've got to rub stuff off, because I've used half of it for the actual table, haven't I? Okay. I'm hoping you find this a useful example. Okay, I made it up myself because I didn't want it to be too difficult. There's no sense in using difficult numbers, so I kept the inequalities nice and simple. I kept the numbers simple as well. 80, go on, 5 1/4, half and 3/4 of 80 is easy, isn't it? So Q1 for the lower quartile, all right? So 1/4 of 80, that's the 20th value we need, all right? 20th value. Which class interval is that in? So the first 8 and the next 30, it's in this class, isn't it? Okay, so I'm going to move my star now, and I'm going to just put it there. Okay, so it's in that interval there, so it's in the 150, less than to H, less than 160, class interval. Alright, and then we do the interpolation bit. Maybe you pause the video, just have a go at it. Yeah, on paper, of course. If you want to just rewind and have the method I had up for the Q2, the median, you can get it up and help you. Okay, you're basically doing the same thing, just swapping the numbers around. All right. Anyway, maybe you've done that, maybe you haven't. Maybe just, you know, maybe just see what happens next by keeping the video playing. Okay. Right. So at the 20th value, so let's count. So the first 8 are there. So we want the next 12 values, don't we? Okay. The next 12 values to get us into this bit here. Okay. So it's going to be 12 values into that. Out of how many? How many values are there altogether in this class? There's 22. So as a fraction, it's 12 over 22 into this class interval. Okay, 12 over 22. All right. So that's the fraction. That's the relative proportion we need into this class interval. Okay. How wide is the class? Well, I made it easy now. I made it all 10. So 12, 22, multiplied by 10. Okay, so you find that fraction of 10, okay, and that gives you an amount. What do you do once you've got that? It gives you a number. You write it as a decimal because in statistics you've got to make it so that it's easy to interpret, so decimals really are preferred for this sort of work. Okay, and then you add on 150 because that's where the class interval starts, isn't it? So add 150, and then you just work out what that is. Okay, so here we go again. So 12 divided by 22. Okay, the great of you, of course, could just write 6/11 if you wanted. Okay, but I'm just doing it's 12 over 22, so you can actually do it along with me. Times by 10. When I do this bit, do you do the calculator thing at the same time? Do you ever have a calculator handy? Okay. Are you one of those people? So I imagine in the Wild West people had a gun handy. So I was talking about guns. Probably could have chosen a better example, couldn't I? But those mathematically among us might have a calculator handy. Okay. 155.45 recurring. So I'm just going to round that to 0.5 just to be consistent with the previous answer. Okay, it's 155.5 centimetres. Okay, and that is the lower quartile. Right, that's the lower quartile. I hope that made sense to you. And now I'm going to do the upper quartile. Okay, finding all three, Q1, Q2, Q3. It's nice because you get kind of 3 examples in one. Right, because you get to see the method 3 times. Right, so if you're still not quite sunk in yet, do the same again, but for the upper quartile. Okay, I'm just going to write. Can I up here? Okay, what Q1 is, because afterwards I'm going to work out the interquartile range. 155.45 recurring. There we go. Remember, when you've got another calculation to do, it's always best to use the exact value, not the rounded value. We're going to do it again, so that's why I put 0.45 recurring. I'll just check it was 0.45 recurring. Yep. So let's do Q3. Right, let's rub it all up again. Maybe you pause the video and have a go. Q3, so 3/4 of 80, so that's 60th value. 60th value. Okay, and that's in the which class interval? So it's in that one, isn't it? Okay, first 65 into there, so it's just in that one. Somewhere towards the end of that bit though, so the numbers could be close to 170, isn't it? Yeah, so it's in that class. What's the fraction into that class? What's the proportion into that class? Always write it as a fraction because that's how we could do our calculation. Okay, what's the fraction? So the 60th value, so that's the first 30. We want the next 30 values to make 60. Okay, so that's going to be 30 over how much? Over 35. So 30 35ths into that class interval. Okay, did I do that a bit too quickly for you? I really hope not. Okay, but basically first 30, then you want another 30 to make 60. So it's 30 numbers into this class interval, 30 numbers out of a total 35, because there's 35 values altogether. Okay, so 30 35ths. All right, multiply it by the class width. Okay, 10, because you want to find 30 35ths of 10, because it's ranging from this to this in centimetres. And then of course, once you've got that value, add on 160, because that's where the class interval starts. All right, and then you just work out what that is. Let's just do that. Okay, so 30 over 35. Okay, multiplied by 10, okay, and then add on 160, yeah, 168.57, so I've got 168.6 centimetres, 1 decimal place. Okay, I'm hoping you got that. Lastly, interquartile range, do remember from the good old GCSE days, okay, you could do that, okay, 168. Let's write the exact value there, 57 ... subtract the 155.45 ... Let's put the recurring dots as well there, okay, dots going on around there, aren't there? Okay. And we'll just work out what that is. Okay, so subtract 155 point, that will do, okay, yeah, so 13.1 centimetres, 1 decimal place. Okay, there we go. That's it. Okay, and that's basically what interpolation is. Okay, I'm going to give you another example. Okay, so this is example 1, the easy example. The other example is, well, it's just slightly different, and you'll see. Okay, right, see you in a bit, I hope. Okay.